Sir, in the last videos, we have seen how to create a binary tree. Okay, how to create a binary tree. And in that, what are the various operations that we can able to perform on this binary tree? I told very clearly in the last session, sir. Sir, now in today's session, we are going to talk about the few more operations on this. So, what are the remaining operations that I am going to explain here is, please listen. So here the task is nothing but level order traversing. Level order traversing. If you have a tree is there, you have to visit that tree level wise. Sir, level wise means what you know already. For example, if you take a tree like one and then its left child is two and its right child is three, and here we have four, and here we have five, and here we have six, and here we have seven. Like this, if you have level order traversals means what one in the next we have to print two, three, and next we have to print 4 5 6 7. Like this we need to print level order. Let us implement how we can able to print this in the level order. Sir, now already we have a tree is there, already we created that. Just my requirement is what, just I am going to explain the level order. Okay, for that what elements we are going to take here is, let us take the same elements whatever we have already, 1 2 3 4 5 like this we have, right? Let us take as it is. How to print the level order? I am going to define one special method for that, def. So level order traversal, level underscore order underscore traversal. Like this I am going to take self, I am going to take. So no need to take any other parameter, just I am going to close here itself. So first step is what? If self dot root is equal to none, that means if there is no elements are there, then simply we are going to return none. Okay. If the data is empty, simply I am going to return none. Like this we have. Next term, sir, to traverse these elements one by one, 11 by level, I am going to take a queue. Okay, I am going to take a queue. So what is the first step is, okay, let us consider this is nothing but my queue. In the queue, first I am going to store the first element, q dot append. So q dot append of I am going to take, so self dot root. So whatever root element is there, I am appending that element into the queue. Let us take one because root node is one, right? So I am appending that one into the queue. So in my queue, one is there. After that, I am going to append none also. So after this, what will happen? It is going to take none. It is going to take none. These two elements are there in the queue. Sir, why I am maintaining queue? You will get the clarity. Until the value, the length of the queue is not equal to, the length of the queue is not equal to 0. Sir, we are going to take temp is equal to q dot pop of 0. Okay, we are going to pop one item from the queue and we are going to store that element into the temporary variable. Sir, what is the first element that we have? One, right? That will be removed from the queue. After this, what we have to do? We need to print that element whatever you have popped. Okay, later we will print that. Okay, and we are going to check. Is the popped element is equal to none? Is the popped element is equal to none? No, right? Otherwise, what we are going to do? We will print that data on the screen. This is nothing but my requirement. After that, I am going to check, is that temporary node left child is not equal to none. Sir, which item we popped one? Is its temp left node is not equal to none? No, it is not equal to none. Then what we are going to do? Q dot append of q dot append of that temp dot left I am going to add. Sir, what is the temporary node left? Left is nothing but what? 2. I am going to append this in the queue. Then similarly, I am going to append right child also. How to check? If a temp dot right is not equal to none, that means for that tree, if a right node is not there, then I am going to append temp dot right. Okay, that means what? What is a right node? 3. This one also appended into the queue. Have you observed? We are removing this one and we are printing that. So one will be printed on the output screen. Then we are going to check. Is its left child and right child are there or not? So left child is there, we are pushing into the queue. Right child is there, we are pushing into the queue. So when you are visiting next time, you will get these two. Okay. Now have a look once. After completion of this, else part got completed. Then what will happen? Again while loop is going to work, right? Since so length of the queue is the length of the queue is not equal to 0. Yes. Then again we are going to pop the 0th element. Now which element is there in the 0th location? None will be popped. If whatever we have popped is not equal to none, these are the operations that we have to perform. If it is equal to none, then what we have to do? Sir, simple. We need to print one empty line. So that what will happen? After printing this one, the control will go to the next line. Because level wise order only we are printing, right? That's why. Sir, after this, we are going to check. Is the length of the queue is equal to 0? Sir, is the length of the queue is equal to 0? No, right? Then what will happen? We are going to, if length of the queue is equal to 0, then we will break. Otherwise, if it is not the case, in that queue I am appending none. Okay, in that queue I am appending none. Sir, now what will happen? Already this none we are extracted, and we cross checked whether it is equal to none. Then we transfer the control to next line. And if my queue is equal to 0, length of the queue no, then we are going to append one more here. Sir, now what will happen? If condition satisfied and this got executed, that's all. Then again check, is the length of the queue is not equal to 0? Yes. Now pop the one more item. Which item? So 2 will be popped. Sir, is that 2 length, I mean, is that 2 is equal to none? No. If it is equal to none, if it is not equal to none, then what we are going to do? We will print that data. So 2 will be printed. And cross check, is left child is not equal to none? Yes. Then append that left child. Check, is right child is not equal to none? Yes, append that right. Like this we have. Then what will happen? It will go to the again. Sir, is length of the queue is not equal to 0? Yes. Try to get one more item. Pop the item. 3 will be removed. Is 3 is equal to none? No. Then what we have to do? Print that value. 3 will be printed. Now identify the left node for 3. 6 is there. So append that 6. Right node is there? Yes. Append that. Sir, then what we are doing? We are going to check. Is length is not equal to 0? Yes. Then pop the item. No, none. Sir, we are going to print the new line character. Have you observed? So to get a new line character, we are going to append this none, sir. Sir, temp is equal to none. We have printed new line character. Is length of the queue is not equal to 0? Yes. Then again we are going to insert none. Then is length of the queue is not equal to 0? Yes, it is not equal to 0. Again we are going to pop one more item, which is nothing but 4. That 4 will be printed. Is there any left child? No. Is there any right child? No. That's why that won't be inserted. Then pop one more item, 5. So is it equal to none? No. Then print the data. Then is there any left child for 5? No. Is there any right child for 5? No. Then again we have to pop one more item, 6. Is it equal to none? No. Sir, print the data. Is there any left child? No. Is there any right child? No. Still queue elements are there. Pop one more item. Sir, is it equal to none? No. Then print the data. Is there any left child for 7? No. Is there any right child for 7? No. Then what we have to do? Pop one more item. None. Sir, is it equal to none? Yes, print the new line. The control will come to the next line. Is length of the queue is equal to 0? Yes, come out from the loop. That's all right. Sir, is this output we got or not? Yes, level wise order we are going to print. So to get this level wise order, just we used one data structure, which is nothing but a queue, because continuously we are adding and we are going to pop continuously. Please confirm how to work with this level order traversal. Is it clear for you people?
Yes, sir.
Right. So let us execute this and cross check whether level order is coming or not. We defined the function, right? Now what we have to do? So already we have created the tree. In order, pre-order, let it be. Then I want to print level order also. So level underscore order. Is it correct function name? Okay, better to return this. I mean, better to remove this traversal. Level order is sufficient. So now what will happen? Let us run this code. I am opening a command prompt. So py space I am taking test.py. One second. I think it is there in different file name. So with name DSA with Python, and the file name is I think BST BT binary tree. Sir, it is coming line by line. Sir, better here. Yeah, after printing, let us give the end as a space. Sir, can I get now? Now cross check. Yes, have you observed? If you take this big tree, like what are the elements? Sir, 1, so 2, 3, so 4, 5, 6, 7, so 8, 9, so 10, 11, so 12, 13, 14, 15, like this we have. Sir, in the first level, 1. In the second level, 2, 3. In the third level, 4, 5, 6, 7. In the fourth level, so 8, 9, 10, 11, 12, 13, 14, 15. Like that we are getting or not? Yes. I think you understood the concept, sir. Sir, is the executable part, is it clear for you people? Please confirm.
Sir. Yes, sir.
Right. So what is the next operation that we have to perform here? We need to see this is level order. I will do one thing. I will add all these functionalities. Later I will return the result. I mean, give the code. Count nodes. How many nodes are there in your binary tree? You have to count. How to write code for that? Very simple, sir. I am going to define one function with the name count nodes. Sir, I am taking self, and we have to cross check how many nodes are there in your tree. Sir, how to do that? If your node, whatever you are passing, you need to pass one node. Okay. So whatever node that you are passing, if it is equal to none, then I am going to return 0. Whatever node that you have passed is not equal to none means we have to count how many nodes are there in the left subtree. So self dot count nodes I am calling by passing node dot left, and right count I am taking. So self dot count nodes of node dot right I am taking. So at last I am going to return left count, right count plus 1. Okay, like this we have to do. Anyway, I will explain. 1 second. Yeah. So let us see count nodes. Sir, if your node is equal to none, then we are going to return 0. For understanding purpose, sound. 1 second. Sir, we have a node called 5. For this left subtree is there, right subtree is there. For this again left subtree is there, and for this left subtree, right subtree, both are there. Now you have to count how many nodes are there. Initially we are passing the root node. What is the root node here? 5. Is root node is equal to none? No, right? Then what we are going to do? We will count how many nodes are there in its left subtree. Okay. So count of node dot left. It will come here. Sir, how many nodes are there in this tree? Again left. Sir, it is going to come here. Sir, how many nodes are there? It is going to call. Then what will happen when you are sending this seventh node? What will happen? Sir, it is nothing but none, right? It's left child. When you are calling for its left child, it will become none. In such a case, it is returning 0. When you are calling right subtree, its right subtree is also none. So it is returning 0. So for its left subtree and right subtree, it is going to return none and none. I mean 0 and 0. Now what will happen? For this 7, left subtree count plus right subtree count plus 1. What is a left subtree count? 0. Okay. Right subtree count 0 plus 1. Here we got 1 node. This value will be written here. That is nothing but 1. And how many nodes are there for 3? Left count is 1. Right count, do you have any right node for 3? No. If none is there, then 0 it will return. So now we are going to get 0. Have you observed? 1 plus 0. 1 plus 1 is there. Left count is 1 plus right count is 0 plus this node count is 1. Total, it will return 2. Here also, sir, it will come left child is 0, right child is 0. So 0 plus 0 plus 1, it will return 1. Its left count is 0, right count is 0. So 0 plus 0 plus 1, it will return 1. So 1 plus 1 plus this node is 1. So it will return 3. Have you observed? In this case, 2 plus 3 plus 1. Sir, what output we are going to get? So 2 plus 3, 5, 5 plus 1, 6. Total, how many nodes are there in this tree? 6 nodes. This is the first one. This is the second one. This is the third one. This is the fourth one. This is the fifth one. This is the sixth one. So just we are checking in the left child how many nodes are there. In the right child how many nodes are there. So current child, current node is going to count it as a 1. Like that we are going to start from the bottom. Sir, is the concept is clear?
Sir.
Please confirm everyone. Is the concept is clear?
Yes, sir.
Yes.
Clear, sir.
Right. Now we will see, sir, here how many nodes are there? I think around 15 nodes are there. Now let us see what will happen. Sir, I am going to print obj dot count nodes of obj dot what we have to pass, root node we have to pass. Then see what will happen if you run the code. Sir, how many nodes are there? 15 nodes are there. Internally, it is implemented based on the concept of tree data structure only. Okay, I mean recursion only. Next, we will see the next one, how to calculate the sum of the elements. Sir, how to calculate sum of the elements? Same thing, sum of nodes I am taking, where self I am passing and then node. Sir, what will happen if your node is equal to none? What is the sum? Last node sum I am going to return it as a 0. And now you have to find out left subtree sum. How you are going to find? Sir, self dot sum of nodes I am taking, where node dot left I am passing. Okay. Sir, right subtree sum. How you are calculating? Self plus sum of nodes I am passing, node dot right subtree I am passing. Then how to return the total sum, sir? Left subtree sum plus right subtree sum. To count, I have taken 1. But we need to calculate sum, right? Then what we are going to do? Node dot data I am taking. That's all. Now have a look once. Very simple task, sir. Consider I have node 3 is there. So 7 is there. So 5 is there. And then 1 is there. Here 2 is there. Okay. And here 3 is there. Just for your example purpose. In this case, what will happen? Do you have any left child? No, it will return 0. Do you have any right child? No, it will return 0. So this node, when you are talking about this node, what value it is going to return? Left sum is 0, right sum is 0, current node value is 1. So it will return 1. Then what will happen? Sir, what is the right subtree sum, sir? 0 it will return. Okay. Now please listen. 0 is the right subtree sum plus what is the current subtree sum? Left subtree sum 1 plus what is the current node? 7. What is the result? 8. 8 will be returned. Similarly, here left subtree sum is 0, right subtree sum is 0, current node data is 2, so it will return 2. Here left subtree is 0, right subtree is 0, current node data is 3, it will return 3. Here left subtree sum is 2, right subtree is returning 3, Current node data is 5. Sir, 8, 9, 10. It will return 10. Left subtree sum is 8, right subtree sum is 10. Current node data is nothing but 3. Sir, what will happen? Is it a 21 or not? Yes. Can you please cross check 7 plus 3? 10. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Sir, total how many? What is the length of, what is the sum of nodes present in the tree? Is it 21 or not? Yes. Like this we have. Can you please confirm, is the concept is clear up to this whatever I covered? Simply we used recursion concept, sir. Clear?
Yes, sir.
Sir, here node dot data will take.
A node dot data we have to take because we are calculating what is our main purpose. We have to calculate the sum of the nodes. So sum of node means this value is required, right?
Okay.
Uh,
For LS plus RS plus node dot data means it will LS also take
left.
node dot data.
No, LS also will take node dot data, but at last node, if you take, what is its left subtree? None, right? For one, what is the left subtree? None. For one, what is the right subtree? None. If you have none and none, we don't have any data, right? In such cases, it will return 0. That's what I mentioned here. 0, 0. When it is calculating for its higher tree, 0 is the left subtree sum. 0 is the right subtree sum. Current node is 1. Its data is 1. 0 plus 0 plus 1. We are getting 1. Similarly, for 7, we don't have any right subtree. If you don't have any right subtree, it will return 0. So left subtree returned 0, 1. Right subtree returned 0. Current node data is 7. Up to this, you can check. 8 is nothing but sum of left subtree. Got it, sir? Sai Kiran. Clear?
Yes, sir.
Yes, Bharat, Abhishek, please confirm. Clear?
Yeah, sir. Clear.
Yeah, yes, sir.
Right. So what is the next operation? But let me cross check. We have to check, right, sum of nodes. Sum of nodes present in this tree. Let me cross check. Sir, we got 120. 120 is the sum. Sir, for convenient purpose, I am going to take one more node, sir. Let it be 1. Sir, now what output we are expecting? 121. Is it coming? Yes. Let me take another value called 2. What is now we are going to get? So 121 plus 2, which is nothing but 123. You can see there is a change in the order also. Okay. This is nothing but what we have. So sum of elements, how you can calculate. Instead of that, if you take a level underscore order, you will get more clarity. Now you can see in the first level we have one, next level, next level, next level, next level we have. So 123 is the result. This is nothing but what we have. Sir, what is the previous example you have taken? That is cool to understand. If you want, you can draw this tree, right? Already somewhere in the last classes I explained. Sir, first we are going to create a binary tree. Then what we have to do? Binary tree dot root is equal to what we are taking? Self dot node of 3, right? Then so obj dot root is equal to, I'm going to take root dot left is equal to, sir, self dot node of, I'm taking, what is its left subtree? 7. What is its right subtree? 5. Like this I have taken, right? Let me execute up to this whatever we are getting. Let us cross check. 1 second, sir. 1 second. Here we need to take, sir, 1 second. Please wait. Hello. Yeah, guys, give me just 1 minute a time. Okay, so I will be back. Please wait for 1 minute. Yeah, let me execute up to this, whether 3, 7, 5 are coming or not. Name self is not defined. I think here you need to take obj dot, because a self you can access only from the class. B tree has no attribute called node. I think it is capital N, right? At the time of creating node class, we have taken capital N. Sir, 3, 7, 5. Up to this we got. Sir, for 7, what is a left child? For 7, the left child is there, which is nothing but 1. Okay. For 5, we have left child is there. Okay. At the same time, we have right child is also there. What is a left child for 5? 2. What is a right child for 5? 3. Now you can see. Sir, 3, 7, 5, 1, 2, 3. That's all right. What is the sum? 21. Expected output is also 21. Can you please confirm now how we calculated this sum of nodes? Is it clear for you people? Please confirm.
Sir,
Yeah,
I
clear, sir.
have found out.
Yes, you can. You can ask.
LS means LS equal to load that means we are recursively calling the RS, so we are not
Yes,
calling
yes,
that
yes. It is going to call
data.
recursively. It is going to call recursively. It is keep on going to check whether
RS is
left node.
calling that.
Sir, your network is very bad, sir. I think so. Your voice is breaking. Sir, please confirm everyone clear up to this.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Sai Kiran, your voice is breaking. Better use chat window for communication purpose. Right. So let us go for the next concept, sir. Same tree I am going to take. The next concept, what I am trying to explain for you people is, I want to perform search operation. Please listen carefully. How we can able to do search operation in this. Let us see. Sir, search operation is very simple. DEF, I am going to take search operation where I'm going to take, okay, so I'm going to give the node and we have to give the key value. You need to check whether that key is there in the node or not. Suppose if the node is equal to none, what is the meaning? We don't have any element, right? Can I return false? Yes. Suppose if that node dot data is equal to the key, then what we are going to do? We are going to return true, saying that element is found. Sir, otherwise what we have to do? You need to call self dot search. So we need to check in that left subtree. Okay, in that left subtree, is that key element is there or not? If it is there, what we have to do? We need to return true. Again, you need to check search function I am calling. Okay, search function I am calling. Sir, where node dot, I am going to check whether it is there in the right subtree or not. Whether it is there in the right subtree or not. If it is there in the right subtree, it is going to return true. So like this we are doing. How many cases we implemented here? Total 4 cases. What is the first case? If node is equal to node, what we are going to do? If node is equal to none, we don't have any element like this. We don't have any element in the tree. Simply it will return false. So whatever data that you are searching is equal to key. For example, consider in this tree, I am giving the value 3 I want to search in the tree. Sir, what is the node here? I have passed 3. What is the key value 3? Is both are matched or not? Yes, then it will return true. Suppose consider I have given the element called 5. Sir, what will happen? First it will search with, because this is the node which we are going to pass at very beginning. Is it equal to null? No. Is node dot data is equal to key? No. Then I'm going to call again search function by passing node dot left. What is a node dot left? 7. It is going to check in the 7, sir, is this 5 is there or not? it is not there. Then again it will call its left subtree 1 comma 5. Is the data is found? No. This condition not satisfied. Then we have to check node dot write. What is this data? 5. Sir, 5 and then key value is also 5. Node dot data is equal to key write. Then immediately it is going to return true. Like that we can perform which operation? Search operation. Sir, how this search operation is implemented? Is it clear? Every node it will search recursively. First it is going to search with the main data, root node data. If it is there, no problem. If it is not there, it is searching in the left subtree and it is searching in the right subtree. Please confirm, is this a search operation code? Is it clear for you?
Yes, sir.
Clear, sir. Yes.
Right. So in some of nodes, we are recursively calling the addresses. See why address concept will come here. Sum of nodes of node dot left. We are passing left subtree. Okay. Left subtree means what?
Yes.
In this example, left subtree of 3 is 7. So 7 we are passing. The node is 7. Is that node is equal to none? No. Again it will call node dot left. What is the left to 7? 1. 1 will be passed. That reference will be passed. Is it equal to none? No. Then again it is going to pass node dot left. What is an one left node? None. If it is none, it will return 0. Then for right subtree also it will return 0. 0 plus 0, left subtree returned value, right subtree returned value plus current node. At this stage current node is 1. 0 plus 0 plus 1. 1 will be returned. So when you are calling 7, left subtree returned value is 1, right subtree returned value is 0, current node data is 1. Sorry, current node data is 7. So it will return 8. Like that it will calculate. Okay.
Okay, sir. Understood, sir.
Right. Now let us execute this search operation, sir. How it is going to work? Now I am going to take obj dot. I am going to call search operation. Just I am going to pass. Okay. Just I am going to pass obj dot search of obj dot. We have to send root node. Assume I want to search for 4. I want to search for 5. Is 4 is available in the tree? No, right? It will return none. No, it should not return none. It should return false. Okay, why it is returning none? False. Why it is returning none? For which value it is returning none? For 4 it is returning none. Since it is not there, 1 second. Sir, at last, if all these cases are false, we have to return false. Now you can see. Sir, here the element 4 is not available. That's why we got false. Because you can see, we are checking if the node is not there. If the tree is empty, what happening? I am explained. Then if the tree, whatever node that you have passed, if that data is equal to the data which you are searching, then it will return true. Then we are searching in the left subtree, then we are searching in the right subtree. If all these cases are failed, then the data which you are searching is not available. Simply we have to return false. This is nothing but what we have. Sir, what is the next operation? You need to find out the maximum element and minimum element. Let us see how to find out the maximum and the minimum. Sir, DEF, max element I am going to take, where it will take self comma node. Then if your node is equal to none, then we are going to return -1. Means what? If empty list, if you are passing, empty tree, if you are passing, then its returned value is nothing but -1. Its returned value is nothing but -1. Like that we are getting. Sir, now here I am going to assume the maximum element is nothing but node data data. Then we are going to find out what is the maximum element in the left subtree. So I am taking max element node dot left subtree. In the left subtree, what maximum element is there? In the right subtree, what maximum element is there? Like this I am calculating. Then what we have to do, you need to return maximum value. I am calling max function by passing m comma r l comma r. That's all. Very simple. Listen carefully. Sir, how this code is going to work? Consider the same tree I am taking, like 3, left subtree is 7, right subtree is nothing but 1. Then what is the next element, sir? So root is 3, its left is 7, so its left is 1. Okay, its right is 5. Then its right left is nothing but 2, its right is nothing but, let us take 4. Like this I have. Sir, now we have to find out maximum element. Please understand the logic. Sir, this is the first node which we are going to pass, root node. Is it equal to none? No. Suppose if it is equal to none, we are returning -1. Sir, otherwise what we are taking? We are going to take maximum is equal to node dot data. This data I am taking 3. Then its left child is equal to max element of node dot left. It will call the same function. Now we are going to pass this one, that is nothing but 7. And this one again it is going to pass 1. Again it is going to pass its left subtree. Sir, its left subtree maximum is -1. Its right subtree maximum is -1. And so current maximum, current node is nothing but max, right? Can I take 1 comma -1 comma -1? In these 3, what is the maximum that will be written here? Sir, what is right subtree? We don't have any right subtree. If right subtree is not there, which value it will return? -1. Now for this, what value we are going to return? Sir, maximum value, which is m value, current node data, which is nothing but 7. What is its left node data, sir? Left node returned value 1, right node returned value -1. So it will return 7 as the maximum element. Similarly, for 2, left subtree is not there, right subtree is not there. So left subtree maximum element is nothing but -1. Right subtree maximum element is nothing but -1. Since the left subtree node is none, right subtree node is none, it will return -1, -1. So current node is 2. So when you are returning 2 comma -1 comma -1, what is the maximum? It will return true. Here also -1 -1 4. 4 it will return. Now observe here 5 comma left subtree maximum is 2, right subtree maximum is 4. What is the maximum value among these 5? What is the left subtree of maximum? Main tree is maximum is 3. Main node maximum is 3. Left subtree returned 7. Right subtree returned 5. Now 3 comma 7 comma 5. What is the maximum among these? 7. Have you observed? The maximum element in the tree is nothing but what? 7. Sir, all these things we are doing recursively only. Recursively we are going to do. We are going to check left subtree. We are going to check right subtree. Is the element is there or not? If the element is there, then we are going to return that node, and left subtree is null, right subtree is null, means we are going to return -1. Like that, we are going to calculate repeatedly. Please confirm, is the concept is clear about this finding the maximum element?
Yes, sir.
Yes, sir, clear.
Right. Sir, next what we have to do,
Yes, sir.
we need to find out minimum. How to find out minimum? Sir, I am going to change the function name as a minimum, and here also we have to change minimum, and here also I am going to change, instead of max function use min. But the problem here is when node is equal to none. See, when you are finding the maximum element, we are going to take, if the node is not there, the least value I am going to take, which is nothing but -1. But if I want to find minimum element, what we have to do? When the node is not available, you have to return maximum value. But we don't know, right? In the list or in the tree, how many elements are there? We don't know. That's why I'm going to take sys dot max size. It will return maximum size, maybe some 10-digit number, 15-digit number, like that. So that what will happen? You can able to see. Suppose in this example, listen carefully. Sir, better for your easy understanding purpose, I will write like this so that you can get clarity. Have a look once. Sir, is there any left right child for this 7? No, none is the left right child. Sir, is there any left child for 1? No, none. Right child, none. For 2, left child, none. Right child, none. For 4, left child is none. Right child is none. So that our calculation will become very simple. Now have a look once. Sir, if node is none, it will return maximum size. Sir, just assume the maximum size is 99. Just for our understanding purpose. Because that element is not there in the tree. That's why. Sir, can I say if node is equal to none, it will return 99. If node is equal to none, it will return 99. Sir, 99, 99, 1. Among this, we have to find out the minimum. Can you tell me among these three, which is the minimum? Please respond. 99, 1, 99, which is the minimum. So it will return 1. Now 1, 7, since you have none, it is going to return 99. Sir, 99, 7, 1. Which value it will return?
1.
Minimum value, 1. Sir, here none is 99, none is 99, current value is 2. 99 to 99, minimum value will become 2. Here 99, 99, current node value is 4. It will return minimum 4. So here 2 comma 4 comma 5, minimum is 2. Here 1 comma 3 comma 2, minimum is nothing but 1. Can I say the minimum element present in this tree is 1? Yes. Like that we can able to find. When you are calculating maximum element, we are going to find the last maximum is -1. From that we will compare. When you are taking minimum element, maximum element we are going to take, from that we will start. Sir, have you observed? The concept is clear, I think so. How you can able to find out minimum and maximum elements? Please confirm, is the concept is clear? Please confirm, is the concept is clear? Yes, please respond.
Clear, sir. But why you use sys max size?
Because minimum element means what? Can I say -1 is the minimum among all the elements? Because -1 is not there in the tree. That's why I am going to take -1 as the minimum for comparing maximum. If I want to compare, if I want to get a minimum, you need to take the maximum. Then only you can find minimum. So what maximum I can take? Can I take 9? No, because in the tree, if 9 is there, then what will happen? That is the biggest problem. Can I take 99? No, because if in the tree, if 99 is there, what will happen? Sir, can I take 999? No, because in the tree, if 999 is there, what will happen? That's why, sir, in the integers, what is the maximum value? Can I take that maximum value? Yes. So that for that I am taking sys dot max size, which will return the largest value, maybe 10 digit or 12 digit number it is going to return. So that thing is not there in the tree. Are you getting my concept?
Yeah.
Because in the list, if you want to find out a maximum element, what you are going to do? You are going to take the maximum element as a -1. In the list, you will compare this -1 with the remaining elements. If anyone greater than -1 came, then you will update that. Because you have taken the least element and you considered. So in the same way, for finding minimum element, so what is the minimum element? It can be anything. So how to find out? Try to take the maximum element. If you take first element, if it is less than that, then update that element. That reverse process is there, right? For the time taking, I think you people got clarity about the finding maximum and minimum. But let me execute. In this tree, already we know what is the maximum and what is the minimum. How to do that? We have to take max element. Is it correct? Yes, max element, and we are going to take min element. So obj dot root we have to pass in both cases. Let us cross check. Sys dot max size we are getting error because Since we are using sys module, we have to import sys. Sir, 7 is the maximum element in the tree. Is it correct? 1 is the minimum element in the tree. Is it correct? Yes, like this we got. Sir, executable wise, do you have any doubts? Friends, please confirm.
Clear, sir.
Clear, sir.
Right. So what is the next one after calculating minimum and maximum element? I want to find out number of leaf nodes. Search operation is also completed. Number of leaf nodes. How many leaf nodes are there? I want to find out. Let us see how you can find out the number of leaf nodes. DEF, number of leaf. Can you please confirm in this node, I mean in this tree, how many leaf nodes are there? Anyone, can you please tell me?
Please, sir.
Just I need to
1,
count.
2, or 4.
1, 2, and then
2
4.
and 4.
Because for these nodes, we don't have any left child and right child. Both should not be there. Sir, how to find out this? Sir, it is a very simple, sir. First, we have to check. Is your node is equal to none? If your node is equal to none, how many leaf childs are there? 0 leaf childs. And for the node, if left child is none, and for that node, right child is none. Can I say, is it a leaf node or not? I will return 1. And we have to repeat this process, number of leaf node by passing. So node dot left and same self dot number of leaf nodes by passing node dot right. Like this we are going to take. Sir, let us see how it is going to work. Have a look once. Please listen carefully. Sir, first we are passing 3. Is node is equal to none? No. Is left node and right node are none? No. Then we are calling the same function recursively for left. Now this is the node. Is it equal to none? No. Is the left child is none and right child is none? No. Then call for this second time. Sir, 1. Is it node is none? No. Sir, is left child is none, right child is none? Yes. So it will return 1. Now for 7, left child is none. For right child, none means what? It will return 0. Sir, what we are doing? Plus right, 1 plus 0, which will return 1. So in the left subtree, we have only 1 leaf node. Sir, same right subtree, it will pass 5. Its left subtree is there, right subtree is there. It will pass 2. Its left subtree is none, right subtree is none. In this case, it will return 1. For 4, left subtree is there, right subtree is not none and none. It will return 1. So 1 plus 1, it will return 2. Sir, 2 plus 1, it is going to return 3. So how to check whether it is a leaf node or not? If left pointer, right pointer, both are pointing to the none, I can say it is nothing but a leaf node. Can you please confirm? Is the concept is clear?
Yes, sir.
Clear, sir.
Right. Right. Sir, let us execute this. So we need to find out number of number of leaf nodes we have to find out. Sir, 3 leaf nodes are there, 1 to 4. Sir, let me take that list, whatever we have taken in the beginning. Like list is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10, 11, 12, 13, 14, 15, like this I am taking. Obj dot create, what is the function name? Create a tree of list. So create a tree of, we have to pass a list. Now see how many nodes we are getting. 8 leaf nodes. Is it correct? 8, 9, 10, 11, 12, 13, 14, 15, like that we are getting. I think The execution wise also this concept is clear for you, right friends? Clear?
Yes.
Right, sir. Let us go for the next one. Just 1 second. Please wait. Yeah, right. So let us go for the next concept, sir. What is the next concept that we have here is, sir, we have completed up to this. So we height of the tree, I will explain later, sir. Okay, in the binary search tree, I will explain. Now you have to print all the paths from root node to leaf. If you take the node called 1, 2, 3, so 4, 5, 6, 7, like this, if you have, this is the first path. This is the second path. This is the third path. This is the fourth path. Like this, all these paths you have to print. How to write code for that? DEF. I am taking the function like print all paths. I am taking self and I am going to take a, a list or a string or anything like this. Okay, let it be. So paths. Let us take path or list is equal to, sir, I am taking one empty list. So self dot print all paths. Print all paths util I am taking. I will pass self dot root node at the same time the list. Both I am going to pass. Sir, in this list, we are going to add all the nodes until you are getting null. Now I am going to define that print all paths underscore util function. Okay, which is going to take node, which is going to take the node and also list. If your node is equal to none, if your node is equal to none, then simply I am going to return, nothing I am doing. Otherwise, s dot, not s, l dot append of, l dot append of your node dot data. I am appending that data, sir. So let me take one example parallelly. For example, consider I have a tree like 5, 1 and then 2. Okay, here 3 and then 4. Here we have 7. Like this we have. Sir, I have a list. Please listen carefully. In this list, I am checking. First, I will pass which node? 5, right? Sir, is 5 is equal to none? No. Then please append the data. 5 is appended into the list. Then what we are going to do? Sir, we are going to check is the node dot left is equal to none. At the same time, node dot right is equal to none. Then what we are going to do is we will print that list L. Okay. And we have to pop one item from the list. Then we will return the control. Please cross check. Is this fifth node left child is none? No. Right child is none? No. If condition not satisfied. then can you please call print all paths underscore util by passing. So which node we have to pass? Can I pass node dot left comma L? And similarly, so we are going to pass node dot right, like this we are passing. Let us see what will happen here. Sir, after doing this, again we have to take L dot pop. Please listen, sir. Sir, first time we got the node 5. 5 is appended into the list. 5 is appended into the list. Sir, then what we are doing? Left child and right child are not none. Then we are calling the same function by passing left child. So 1 will be the next node. For 1, again same function. Is node is equal to none? No. Sir, append the data. 1 will be appended. Is its left child is none and right child is none? No. Then again call left. So 3 will be passed. So append that 3. Sir, is it left child is none? Yes. Is it right child is none? Yes. Can you please print the list? What is the list that we got, sir? 5, 1, 3. This is the first list, right? Then L dot pop. Pop means what? It will always remove the last element. Sir, up to this, do you have any doubt? First path we got or not? Yes. Any doubt, friends? Please confirm. Any doubts up to this?
No, sir. Clear.
No.
Sir.
Sir, what we have to do the next one? Sir, left child completed. Same operation is going to call for right child. What is a one right child? 4. Now what will happen? Print paths of 4. Is 4 is equal to none? No. Append the data into the list. I am appending 4. Is it left child is none? Yes. Right child is none? Yes. Print the list. What is the list? 5 comma 1 comma 4. Then pop the item. Which item is going to be popped? 4. Now please listen carefully. This left child, right child, visiting completed. Then L dot pop. Can you please pop one more time? 1 will be popped. So this part completed. Go to right child, which is nothing but 2. Sir, now what will happen? Is node is equal to none? No. Append the data. 5 and then 2. Sir, is it left child is none? Yes. Right child? No. Then what we have to do? We are going to pass left child. Since left child is none, it will return the control. And right child is there, right? What is the right child? 7. Is node is equal to none? No. Append the data. Is its left child is none? Yes. Is it right child is none? Yes. Then print that path, which is nothing but 5 to 7. Then delete the item. Which item? 7 will be deleted. Sir, it's left child completed, right child completed. Can you please delete this? And root node, left child completed, right child completed. Delete this. That's all right. Like this, we got the path or not? Yes. 513, 514, 527. Is it the path? Yes. If you see 513, 514. So 527. So it is printing all the paths or not? Yes. Sir, for this tree, just I am asking obj dot print all paths. Okay, print all paths. Just yeah, that's all. Now have a look once. Have you observed for this big tree 1 to 4 8? If you want just parallelly, I will draw. So 1, 2, 3, like 4, 5, 6, 7, then 8, 9. So 10, 11, 12, 13, 14, 15. Is it the tree? 1, 2, 4, 8. Yes. 1, 2, 4, 9. Yes. 1, 2, 5, 10. Yes. 1, 2, 5, 11. So 1, 3, 6, 12. 1, 3, 6, 13. So 1, 3, 7, 14. 1, 3, 7, 15. Like all the path came or not? Yes. Hope you understood the concept. Sir, how to print these paths? Is it clear, friends? Clear?
Clear.
Yes, sir.
Right. This is nothing but what we have, how to print the paths. Then, sir, next equality is there and copy tree is there. This I will explain tomorrow. Okay, sir. Tomorrow also we have a session with the same timings, sir. Okay, tomorrow also we have a session with the same timings. So 8:15. Okay, from 8:15 to so up to 9:15, 9:30 I will take tomorrow. So tomorrow I will complete this equality, copy tree, binary search tree theory, binary search tree implementation. And on August 15th also we have a class. There I will cover AVL trees. AVL trees. Okay, this is nothing but our 2 days plan, tomorrow and day after tomorrow. With that, trees are going to be finished. Okay, right, sir. Please kindly attend these 2 days. So I will upload the running notes within few minutes for all the batches, and I will give access for everyone. Okay. Thank you, sir. See you tomorrow.
Graphs, sir. Graphs.
Graphs also will be covered after that. First, we need to see tree.
Thank you.